FASHIONTECH Alliance involves higher educational institutions, small, medium and big enterprises and a research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a FASHIONTECH residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of FASHIONTECH learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community, and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use and reuse. Ready to learn more about FASHIONTECH? Enjoy the lecture!
Hello, the title of today's brief lecture here is Sustainable Development Goals Operationalisation for Digital Fashion Value Chains. And my name is Jonas Larsson, and I work at the Swedish School of Textiles. For this lecture, the aim to start with is to give you an overview of how to approach the Sustainable Development Goals and use them to develop digital fashion value chains. For this, I will first introduce a conceptual framework where I go through the Sustainable Development Goals, and then we have a look at the Textile and Fashion 2030 progression model. Then we will also have a look at some examples of applied projects in relation to circular economy and FASHIONTECH. So the connection to FASHIONTECH here, this comes from a former project within FASHIONTECH that we did that identified 5 trends for FASHIONTECH. There were protection and body enhancement through artificial second skin, culture-driven wearable, art, technology and innovation, hyperbody, connecting senses and materials, fashion takes care, and real virtual mixed environment. We are gonna focus on the 2 last, fashion takes care and real virtual mixed environments. So why do we do this? Well, we do this because there are a lot of waste in the current apparel and textile system. Only on average about 59% is sold at full price at the retailer. To be more studied, but it may be so that only 50%. So we might have 100% overproduction. 60% of jeans customers have a hard time finding their size. This means that if you have a hard time finding your size, you're normal. 21% average return rate in Sweden, 35% for fast fashion, and up to 70% in some specific cases. 60% of returns are due to not meeting customers' fitting preferences in Sweden, and I think also this relates to Europe. We have 14 kilos of textile consumption in Sweden, and 7 kilos disappear or becomes waste every year. Globally, we only have about 1% meaningful recycling. And I would like to have this quote from a friend of mine that if you look objectively at the apparel system, you would think that the people who built it are stupid. And I think that if we look at the data, that can certainly be the conclusion. We will come back to more data here in a while and why this is true, this quote. So the climate impact, and of course, this is just climate impact. And the climate is just one of the 9 planetary boundaries. So there are more like impact on biodiversity, impact on water, impact on air, impact on eutrophication of the seas and things like that. But if we look specifically on climate impact, 80% of the climate impact comes from manufacturing the garments, and about 80% of those 80% comes from the wet processes, so finishing and dyeing. We also see that user transportation stands out with 11%. And this user transportation, that is when you drive your car or take the bus or so to the pickup point or to the store to get your garment. If we look at data from global textile value chains, and we see here on the vertical axis, we have sustainability impact. 0 on this axis mean that you have a sustainable system. -100 means that you're not doing anything. And right now, the industry in general performs at something like -58. So roughly a third of the processes to be sustainable we have in place. If we look at this graph a little bit more in detail, we see that the line here, the big line, the big arrow, doesn't really meet or never reaches the 0 line, the sustainable line. And this is because the aims and the targets we have set up for ourselves in the industry, they don't allow for us to reach a sustainable state. We form targets like we gonna have manufacturing without unnecessary environmental impact, but then that opens up for a lot of interpretation. If someone says, yeah, but no unnecessary impact, it was necessary for me to pollute that river, so that would make it okay then. So we have to set targets for ourselves that allows us to reach the goal, to have a sustainable state. And this is that leap that I indicated here. We have to take a leap in our way of thinking. So how do we do? What do we do here? Well, we practice a lot to reach this sustainable state. All the projects that we do, we try to make them applied, and that's the way for us to practice, so that when the industry is ready, we should have the solutions ready to show them that here are the solutions, here's the way to be sustainable. And as a guide in this work, we use the Sustainable Development Goals. They're a very efficient set of goals and very helpful in this work to reach the sustainable state of the industry. You are all familiar with them. There are 17, and why they're good? Yeah, they give us globally accepted framework for sustainable development, one single language. Also, most companies that you will work for soon have to relate their operations to sustainability, and many of those companies already are choosing the Sustainable Development Goals as that framework. The SDGs, together with tools from, for example, Global Reporting Initiative, offer a comprehensive approach to assessing the sustainability aspect of any work, academic or applied. Difficult may be that the Sustainable Development Goal indicators can at times be difficult to relate to or apply. Just a heads up on that. So how is the world doing? Well, I'm gonna toot the Swedish horn a little bit. Sweden is doing very well on sustainable development. We're very much at the forefront, followed by Nordic countries, other Nordic countries, France and Germany, and so on. It probably doesn't look as good further down the line, but most countries are working on this question, on these questions, more or less. So, how to work with these goals? How do we approach this? Well, one easy way of doing this is to figure out how does these goals relate to each other. And goal number 12, responsible consumption and production, is it's a very good start, because goal number 12 relates to many of the other goals. So if you have positive impact in goal number 12, you will have positive impact on several of the other goals too. You will partly fulfill several of the other goals. So this is a sort of an efficient way to work. If you improve on the indicators in 12, you will do that in the others as well. So how do they look? Well, for one example here, related to the apparel and textile industry is, for example, goal 12.5, which is by 2030, substantially reduce waste generation through prevention, reduction, recycling, and reuse. And then the indicators for that is national recycling rate, tons of material recycled. And this is national, of course, can be difficult to relate to if you're one single company, but as long as you're making designs that last longer, that use less material, that are more recyclable, and that fits better in existing and future recycling loops or recycling infrastructures, you will sort of get to that goal. But there are ways of breaking down these goals even further, and this you can use the business reporting on the SDGs from UN Global Compact. And this report offers a complete list of indicators and business actions for the SDGs. It's a pretty heavy book, but it's once you start to look at it, you realize that it's very useful and can be very helpful in your work. And the indicators that are presented here can be used as inspiration for action, a framework for designing research, or as tools for measuring impact. And it's essentially set up like this. You have the goal number 12, then the sub-goal 12.5, and then you have possible relevant business actions to help achieve this target. For example, tracking and reporting waste generated by type, treatment, and disposal destination. Understand the waste caused as a result of the design and products and services. This is, of course, very relevant for textile and fashion. You can also start implementing circular business models, such as using renewable, bio-based, or fully recyclable inputs, recovering resources, extending end of life, and so on. If you want to go very much into detail in how to measure this, you can look at also the disclosures for 12.5, and for example, materials recycling and waste management. How large percentage of recycled input materials used in the manufacture, the organization's primary products and services. The total weight of hazardous waste with a breakdown by the following disposal methods are applicable, and so on. And there are many more indicators that you can have fun with if you like those. Okay, so how do we relate this to the textile and fashion industry, the SDGs? Well, one way of doing it is chosen by that we have chosen in the project Textile and Fashion 2030, the sustainable national platform for apparel and textiles in Sweden. The purpose of that is to create awareness, drive activities, educate and support the industry and stakeholders on their journeys towards meeting national environmental targets and creating circular textile and fashion system. And in this project, we have chosen these 7 SDGs. So it's 6, clean water and sanitation, 8, decent work and economic growth, and 9, industry, innovation and infrastructure, 12, responsible consumption and production, 13, climate action, 15, life on land, and 17, partnership for the goals. And why have we chosen these 7? Well, these were identified in a materiality assessment that was done by the Swedish EPA. So these were the most relevant goals for the textile and fashion industry from a Swedish perspective. I think it would look somewhat similar in a European perspective. I'm not so sure about the global perspective, but from a Swedish perspective and possibly a European perspective, these 7 goals would likely be in focus. So how do we work with them? Well, to make it very easy for the companies who join us, we created something that we call the progression model. And the progression model is a way of relating what you're doing right now to the SDGs and to sustainability. So we identified 3 areas that were sort of 3 general areas. These were sustainability in general, then product design and product development, and production. And why have we chosen design and product development and production as such focus areas? Why not retail? Why not end of use? Well, we have chosen these because this is in production, that is where 80% of environmental impact happens, and in design and product development, that is where the environmental impact is decided, depending on what material you use, depending on what chemicals that you want, that will have impact on production. So these 2 areas are very important. General sustainability, this is where end-of-use processes, communication with consumers, retail operations, and so on are located. So the levels then, well, we have level 0 here, beginner level. These companies who are at this level, they have no strategy and limited knowledge of where to begin. Level 1, foundational. These companies have processes in place to follow laws. They comply with these laws. They understand how they can work with sustainability, the sustainable development goals, and so on, to become better. Level 2, progressive. These companies plan and demonstrate improvement. And level 3, aspirational. These companies who are here, they innovate and work with a change at a systems level. So they work together with other industry partners, or NGOs or other stakeholders to change the system to become more sustainable. And so how we do it is that we do this with the companies. We interview them and we understand how they perform right now. And when we've done that, we help them to prioritize actions and later to follow those actions, follow up those actions, and measuring them with the sustainable development goals, and using, for example, this report that we looked at earlier. So quite a straightforward process. It takes some time, and it can be in certain cases a lengthy process. So companies right now are in general performing at foundational level. They know that they follow the laws, or they have the processes in place to follow the laws, and they sort of plan to demonstrate improvement right now. So yeah, around 1.5 right now. So yeah, I'm not going to go into details about these, just have them as a reference if you want to look at this, if you want to use this model, then you have them more detailed here. So circular economy, I think it's important to understand this concept quite well. I'm sure you're all familiar with the image here on the left, and but what I want to highlight here is the 3 principles of the circular economy. So the first principle is to design out waste and pollution. The second one is to keep materials in use. And the third one is to regenerate natural systems. And the third one here is very often forgotten in the type of projects that companies normally do around circular economies. It can depend on many different things. What I also think is important around circular economies is to highlight this. Normally, you have to have design, material, and a business model. You have the circular design methods. You have to use circular materials, and you also have to have a business model or a circular business model. And one mistake that is often done here is that you think that there's a trade-off between these. So if you just have super circular material, that means that you don't have to spend so much time on design and business model because you have such great materials. The same way, if you have a fantastic sustainable design, you don't have to and you don't have to think about your business model because your design is so great. But that's not how it works. You cannot. There's no trade-off between them. They come as one. So design, material, and business model have to move up together. So for understanding this a little bit better, you can look at this this matrix from the Delegation for Circular Economy in Sweden. It's a matrix where you have the circular design principle, and then you have usage here. So before, during, and after usage. And yeah, you have the circular principles with the addition of one here, which is to decouple economical growth from extraction of more raw material. And then for each of these phases and for each of the principles, you can have a look at design. You should have a look at design, material, and business model. So for example here, design out waste and pollution. Well, here, for example, you can work with more efficient manufacturing processes that doesn't have any wet processes, that uses digital tools instead. And for each of these, you go through. So the question here is, are there any digital tools that can help? I think this image also from a prior FASHIONTECH project, the Education for FASHIONTECH project, is important to highlight. It highlights where in the sort of development process things typically stop and where they are typically given a lot of focus. So we have here, for example, the start of the, for example, product development process: definition, knowledge and research, context of use, inspiration in materials, scenario formulation, finalization, concept design, evaluation of technology, prototype, test, iterate for a solution, and possible applications. And these dots here indicate where higher education institutes, research centers, and company normally focus. And you see that they tend to focus somewhat on the same things. Companies tend to focus a little bit more on testing. What we try to do to sort of also cover this is to be around here to iterate for a solution and also to find possible applications. That is where we typically work in our projects. So we try to sort of fill these blank fields here. So some examples of projects in the context of circular economies. So what we've done is to try to create systems that are fully circular. We know that they can't be 100% circular, but they're fully circular as much as possible and creates as little waste as possible. And for this, we have worked with digital tools for design and retail. We have worked with digitally enhanced local manufacturing. We have worked with transformative communities and also automatic or autonomous delivery vehicles. We have worked with redistribution of garments, remanufacturing of garments, and service and upgrades of used garments. And for this, what is very important here are the two perspectives. We have the design perspective and the system perspective. The design perspective really is about several things, not only making things look great, but that is one very important thing. So we have the sort of sensory perspective of the design perspective, making things that attracts us, that are beautiful and want people to use these sustainable products and services. But then we also have the design thinking processes, where that is the process that we use to make new projects and new processes. We also very much use the problem solving capabilities of typical designers, since they are normally looking at things from different perspectives. And these perspectives are normally very, very good to bring into projects, since it's always different and it becomes much better. We also have the systems perspective, where we use, for example, the Sustainable Development Goals or the Higg Index or something like that to understand how the system is connected, so we don't sub-optimize. So principle number 1, design out waste and pollution. So the first project we did here, or one of the first projects, was from roll to bag, and this was very much a zero waste project. We didn't want to make anything unnecessary in any of the steps, and we tried to take this very much to the very extreme, which is risky. But it was a European project, and the idea was that we had sort of digital showroom or digital sales channels, where this customer who walked into, for example, the showroom, used the 3D scanner, used the configurator to make his or her garment. This garment, or the manufacturing instructions for the garment that this person ordered, was then sent to printing first. So we printed the garment pieces on white fabric. We cut them, and what is great with this is that the white fabric that is not dyed is fully recyclable. Then the garment was assembled and then delivered, and then to the customer. And we also wanted to make sure that the final garment was fully recyclable. So we set up it like this. We had a 3D scanning to get the measurements of the person. Then we fitted a garment onto that using kinetic garment construction, which is a bit different from normal garment construction, since this very much more follows the movement of the body rather than the tailor's matrix. So this is quite fascinating. You can have a look at that. Then we sort of put this garment into a digital fitting room so that it would see how it looks. And this is a bit. This was very difficult. This we couldn't make this work properly. The biggest obstacle in this process was really how the system integration. We had the digital software. We had a software for digital pattern construction, digital design. We could render the products with this software, but there were so many softwares involved. And these didn't speak to each other. Even if you had the same file format and you had it looked the same in all of it, they didn't speak with each other because they had different accents of how they spoke. So one thing that we did in one of the programs or one of the softwares just didn't work in the other, even if it was supposed to. So this was very difficult. You will see in the coming projects how we work with it. Okay, for this we use digital print. Here is sublimation printing, where you first print on a paper and then you transfer that onto a fabric. And here is direct pigment printing for cotton. This is. Then the garment pieces was cut using this automated cutter, and this is quite a fascinating tool. It sees the contour of the print, and it cuts accordingly, and it cuts very much exactly how it's supposed to. So this is a very useful tool for this type of design applications. So yeah, that project, the From Roll to Bag project, I would say, even if it was approved, it was not complete success. Parts of it were great. The digital rendering and all that was very, very difficult. So what we took, we started all over again, and we formed a new alliance, and we had a project we called it Digimode. And that was a similar purpose, digitally enabled local fashion value chains. And here you see the partners that were in the project. As in the From Roll to Bag project, we wanted to build a local digitally enhanced value chain. So we had a virtual fitting room here, and we had so virtual design and sales technology. Module 2 was a local digital demand-driven production, and Module 3 was the cloud service that took care of the orders that the consumers sent, and sent those orders with bill of material, cutting instructions, tech packs, and all that to manufacturing. That then cut sew and cut and sew processes. And for future projects, we want to work with robots like this to make this process even more efficient. So this is the virtual fitting room. The customer adapts the avatar according to their measurements, and when he's happy, the person is fitted, or the avatar is fitted with this garment, and sleeves are lengthened if they are too short. Torso is lengthened if it's too short, or if you want some bit of heater on your butt. Then this garment is sent to, you have an order button, and then the garment is sent to manufacturing. This was done locally in the city where we are, and if the machine was waiting for this to happen, it could take something like 3 hours from order to finished garment, and at the price, well, quite a high price point, but still a price point that was acceptable for the consumers. Yeah, there was many challenges with this project. There was primarily the complexity of both the garment system, and we're not going to go through the system, but this is how the sort of back-end system looked, and all of these boxes and arrows, they needed attention for each order, manual attention, and that of course is very difficult. So, but now such systems exist both from Gerber and Lectra. Of course, this also added complexity to the garments. Since we wanted to make made-to-measure garments, we needed something like 3,500 different markers and bill of materials to cover for all the different sizes. And somebody had to make them and keep track of them. The production price, we manufactured locally in Sweden, so which makes which of course makes it expensive, and so you would have a hefty price tag, but it was okay from the consumers. Also, software development. Even if this project turned out better than the from roll to bag project, it was still a problem with incompatibility between 3D softwares. So the software where you made the garment, the design software, didn't want to speak to the presentation software, so the app where we showed it to the customer. And this was a bit of a drawback. And this mostly came down to material simulation, that we could not simulate the material in the app the way we wanted to. One of the problems with making made-to-order garments like this is that is sourcing fabrics and also sourcing the right color of the fabric. Because you don't want to buy minimum order quantities. Well, you have to buy it, but you don't want to, because you might be stuck with 300 meters or 500 meters of one particular color in inventory. Then for that purpose, one of the colleagues at the Swedish School of Textiles have developed a digital dyeing machine that, instead of dyeing the whole fabric in a wet process, they spray on the dye on the fabric. So you can make 1 meter or 30 centimeters of that particular color that you want. And this technology, it's not only good for making more flexible production, but also it saves a lot of chemistry, energy, water, and dye. So transparency then, very important for the textile value chain. If you live in a house like the one here on the image, with glass walls, you would probably want to keep your house tidy, because the people who walk outside and look into your house, they will see if it's dirty and messy. And this is the same idea behind transparency for a textile value chain. You want to keep, if you have a transparent value chain, you will keep your operations tidy. So transparency, it is necessary to ensure all stakeholders have access to information about affairs that affects them and to stop corruption. It is necessary to ensure producer responsibility. It is necessary to facilitate consumer-facing communication of sustainability impact, and it is also very good for enabling more resource-efficient production, logistics, and end-of-use processes, etc. But what is so difficult then with transparency? Well, this simplified version of the global supply networks indicates why it's difficult. You have many entities, you have many tiers, you have the material level, you have the chemistry level. But with this, where I think this image is good, is because it tells you where is the tiers. You have tier 1, tier 2, tier 3, tier 4, and it indicates what production step that belongs to each tier. But what I think it's also does well, is that it highlights the chemistry dimension also of the value chain, which is very often forgotten when we speak about transparency. We mostly speak about material transparency. But how can we work with transparency here? Well, one way of doing that is to use digital tools, such as sensors, to collect sustainability data from the different tiers. So collect sustainability data from raw material, from spinning non-woven processes, from weaving and knitting, from cut and sew, all the way. And this sustainability data is typically greenhouse gas emissions, waste, water use, water effluents, energy, toxicity, eutrophications, and emissions to air. So having sensors of different types placed at the manufacturing places can help to get this data. And when you have the data, we summarize that data and make that data available to the stakeholder in the value chain that needs it. So for example, the customer, they can have a tag or a label at the garment that looks maybe like this, an A, or it could be a B or a C or a D or an E also, depending on how good this garment is. An easy communication vehicle for them to make a quick decision at the retailer if this is a garment I want to purchase or not. The retailers can use this sustainability data for reporting and showing to governments that they are becoming better. And for manufacturing, it could be very useful for resource efficiency. But how do we use it? Well, ASKET, which is a Swedish brand, they have something that they call their impact receipt. A simple old-fashioned receipt that indicates the environmental impact from a garment. We also have PAPERTALE, which is a good example, I think, of blockchain-based transparency. So here you have actually my PAPERTALE page, my wardrobe, my ethical score. This is also RFID based, so every garment is equipped with an RFID tag, so you can scan that tag and see where your garment comes from and who has been involved. There also is the compensation program. So, but what I think is great with this one is that you can actually, using this blockchain technology, you can meet the craftsman that's behind the garment and visit the factory also. But also you get the product journey, and you get it all the way from fiber formation. So this is, you see here, Australian cotton registered by Safir Fibers Limited in Pakistan. And you also see the water consumption and CO2 consumption. So you have a very good transparency in this system. So number one, principle number two, keeping things in use. Here we have worked with digital tools as well. So we worked with a Swedish brand called Monkey. They are under the H&M group. And what we wanted to do here was to, one, create more circular processes, and two, create more loyalty between Monkey and their consumers, and three, create a better in-store experience to make people come to the store. So what we did was we put this this printer, this direct-to-garment printer, which is very flexible. It can print now on most materials: cotton, polyester, silk, leather, yeah, all different types of blends, as long as it's 50% cotton or more. So we put that in the store, and then we invited users or customers to Monkey to bring their old garments to the store, and we will have them updated for free. And we also created this tool, this virtual sort of design tool that people who came into the store could play around with and see where they wanted to put these stickers and see how that would turn out at the finished garment. We had sort of standard garments because it was difficult to get all customers' garments inside there, but we had t-shirt, sweatshirt, a pair of jeans, and a normal shirt, I think it was. This was very popular among the consumers. They really, really enjoyed this. They all said that it was a great tool, and it was a really fun project to make. Also keeping things in use, Fact Movement. It's a national Instagram-based network of factivists. It's very much based on social pressure, that you want others to, that you want to do what your friends are doing. But what it's all about is about keeping things alive. So each of these factivists, when they join, they promise that they will not buy anything new for half a year. But instead, we teach them how to mend the garments, how to style, to use what they already have in their wardrobes to style and get new outfits from that, to buy secondhand and to swap things with their friends. So, but what does this have to do with digital tools? Well, in this project, we used wearable technologies to measure and understand how the factivists use their garments. So how was the garments moving between the factivists in the system, and who used it more, who updated, and then we wanted to give scores to the one who were more sustainable, and sort of to also to incentivize the people who were not as sustainable, to make them more sustainable. This was built on the ideas of social physics by Alex Pentland. And how that works in general is that you incentivize good behavior in the system, but you don't give the incentive to the person who behaved well. You give it to the system instead. So for example, if E here does something well, the incentive, money or something else, goes to F or H. If E wants the incentive, wants money, or he or she has to convince D or B to do something good. That's the only way he can get money. So by doing this, by incentivating good behavior, and by then this system ideally will start to behave better and better and better, because people inside the system are constantly trying to push each other to do good things. I think this is a very interesting idea, and we want to try this in the future also. But what was so the study that we did, it was difficult to get the data. We didn't have good enough processes to pick up all the data and to make the proper analysis. But it was a fascinating project to think about in these terms. Anyway, fact movement has moved on and is now national, and this is now resting a little bit. But what we realized from this project was that people are actually willing to have technology in their garments if there is an incentive for it. Coming back a little bit to the data that we spoke about in the beginning, that 11% of the carbon emission from Swedish textile consumption and fashion consumption comes from sort of last mile delivery. We realized that, and we said that, well, if this is a problem, then let's build a robot that can help to fix that. So instead of people getting in their car and driving to, and the car weighs 2 tons, drives some uses fossil fuel, instead of that, we built this little autonomous delivery robot that can take care of that last mile delivery. So getting to the pickup point or driving to the store to pick up those things that you want and getting it to your home. And so that was one of the insights to build this robot. The other one was that we were thinking about, why doesn't the sharing economy work? Why is it so difficult? And then we realized that maybe this is because of sharing. There's a lot of work around sharing. You have to make sure that the things are nice. You have to drive with your car or your bike, or you have to spend time. It's a big logistics cost for the people involved in the sharing system. So we thought, but maybe if this robot can help that and reduce that cost to almost zero. So with the insights from fact movement that people are willing to use technology, and the Hugo delivery system, that works, and with the addition of the Wiliot battery-free Bluetooth technology, we realized that we can build new types of systems. We can build a system with talking garments, and the garments would be able to create money several times during their lifespan. It could look something like this in your phone. So your garment says, "Hey, I've been sitting in your wardrobe for the last 6 months. Don't you love me anymore? No, it's not you, it's me. I've changed and we're not a match anymore. Okay, do you want to sell me? Yes, you would be better off with someone else. Okay, there's actually one who's willing to pay 40 euros for me at eBay. Should I sell me? Yes. Okay, can Hugo pick me up tonight? Yes, at 8 o'clock. Okay, great, pick up at 8. And then everybody's happy. So with these projects that we've done, this little system that we've created, we think that we have a sustainable system. But considering all the damage that we've done to the globe, we are probably going to have to look into how we can have partly positive impact on the world, at least. So we have, that brings us to the third principle, the regenerate natural systems. And there are many ways of doing that. We have tried to put that to use digital tools. In this process, but what does to regenerate mean? Well, it means to improve a place or system so that it's active or producing good results again. It could mean to grow again or to make something grow again, for example, new tissue or a new part. Or it can mean to develop and improve something, especially by making it as good as or successful as it was before. So in addition to the transformative community, the fact movement, and the ideal factory that I spoke to you about earlier, we added sort of regenerative agriculture. And this regenerative agriculture might be a bit specific. We perhaps, it should be regenerate ecosystems. We still have the design perspective and the systems perspective here. Our approach to this is, one of the approaches I would say is the mono no avare, which is the Japanese idea world around the cherry blossom. And the essence of it is to appreciate the transience of things. The cherry blossom lives for a very short while. It falls to the ground where it becomes nutrition to the tree again, and which then makes new flowers. What is very important in this system is that there is no waste in this system. In nature, in general, waste doesn't exist, and we want to think about fashion in the same way. So the project that we currently use to do that is called STREAMATERIA. And these garments, we do this together with a company called Goringo Design Studio. And these are garments that are designed to dye. They follow the principle of a leaf. You see this Puma garment here on the right, where you have the black lines, that is sort of the veins of the leaf, and you have the white coverage, which is the sort of the skin of the leaf, if that is the correct word for that. So, and this also is a part of an ecosystem, the STREAMATERIA ecosystem. So you have the digital platform where you buy, and one thing that is very important here is that these garments are not designed to live for a very long time. The original idea was that they should live for only 48 hours. The first samples live longer, but they are not designed to live longer. They are designed to die. But first you buy this garment on a digital platform, and that is then instantly and locally produced. We use 3D printing technology to manufacture it. Limited, then you have this limited time usage of maybe one time. Then you put it into the household food compost, and which is in Sweden at least sent off to a biogas facility, which makes energy for buses or households from it. We have done a LCA assessment of this garment, and it is as sustainable as food, essentially. Has the same climate impact as food. Summary of how digitalization can support SDGs in fashion value chains. Well, with the digital tools for transparency, traceability, visibility, etc., we can identify waste and pollution and remove that from our value chains. With the digital tools such as active and passive information tags and digital machinery for upcycling, we can help users to keep material alive. And new approaches to designing and making fabrics and owning them can be beneficial in circular economies. And what you've seen here is that digital tools are very central in all of these projects. We haven't used one specific type of digital tools, but we have used several approaches to digital tools, as long as they help to serve the purpose. With these ideas, we think that we can have partly positive impact on the textile value chain and build regenerative systems. And with that, I want to thank you for listening and enjoy the rest of your day.